Alright, once again, we are talking about general equations and kind of how to solve general equations, especially maybe two-step equations that might be looking like something like this. Ax plus b equals cx plus d. If we've got variables on both sides and numbers on both sides, what do we do? Alright, step down here. Here's our steps. We talked about parentheses and like terms in the previous example, and now step 2 says step 2 and 3 really we can kind of combine because it gives us the idea of using the idea of the middle school dance where you go variables go to one side and numbers go to the other side. Just like at a middle school dance, guys usually go to one side of the dance and girls usually go to the other side of the dance, and guys talk about cars and football and girls talk about whatever they talk about over there. I'm not really sure. But anyway, step 2 and step 3 allows us to put the variables to one side and the numbers to the other. And after that, we use step 4 to divide by any coefficient that's in front of the x, and we solve. So let's go to some examples. Here's clearing parentheses by multiplying the number that's outside the parentheses by every term that's inside the parentheses to get to just terms. And then what's a like term? Like terms have exactly the same variables to exactly the same powers. So now we're to the situation where we might have a situation where we might have to solve something. So if we've got some example, here's the I guess the description up here. Whoops, hang on a second. There we go. Description up here talks about moving stuff first. What do you move first? Because if you've got variables and coefficients and numbers, what do you move first? Well, I like the idea of cleaning your closet. When you go to college, or when you move, or when you clean your closet, let's say, you look through stuff and you say, I'm attached to this, I'm not attached to this. You take a look at the sweater from Aunt Sally and you say, ooh, I'm not so attached to that. It's kind of an ugly Christmas sweater. I'm getting rid of that one first. So those sweaters from Aunt Sally are right here. Pretend that you're the variable. Sweaters from Aunt Sally are right there, and we want to move those away. My apologies to anybody named Sally, by the way. You're the variable. You want to clean your closet. You move stuff away that you're not so attached to. You're not so attached to that plus 5. You are more attached to the 3. The 3 is like a favorite yearbook. Oh, that yearbook. Oh boy, that was so nice. I gotta remember. I gotta have those memories. But the sweater from Aunt Sally, I'm not so attached to that one. I'm gonna move that one away first. So move away those ones, those things that you're not so attached to. You're the variable here. You're not so attached to that. Move that away first. So your first step would be to solve that one. 3x plus 5 equals 0. I'm not so attached to that 5. I'm going to move that away. I'm going to move that away first. And we'll see how we do that over here. So again, if we're going to solve, and my instructions, I suppose, should say solve. What does that mean? Tell me what the variable is. X equals something. Here's an x, and I guess here's an x as well. But whatever that variable is, you got to tell me what that x is equal to. And not just the x, but oh, by the way, you got to remember that it's 1 times the x. We'll come to that pretty soon. Is equal to some number. All right, so 2x minus 7 equals 11. I'm solving for x. What do? I got to move that 7 away first. What do? I've got to do the opposite of whatever that is. If it's subtracting 7, I want to add 7 to the left side. And because we're treating these equally like kids at Christmas time, this one is equal to that one. And if you're adding 7 to the pile over here, you got to add 7 to the pile over here. What that does over here, minus 7 plus 7 becomes plus 0. So what's left over here? Negative 2x equals 11 plus 7, 18. And now we're to the point where so we're playing the middle school dance. Variables go to one side, numbers go to the other side. Now we got to say, let's solve by saying, I don't want negative 2x. I don't want to know what negative 2x is. I want to know what 1x is. So we divide by negative 2 so that on the left side, negative 2 divided by negative 2 is an invisible 1. X is still over here. On the right side, we just solve. 18 divided by negative 2, well, positive divided by negative is negative. 18 divided by 2, 9, and I'm done. 1x equals negative 9, and we're set. All right, same thing over here. 2 equals 1/5 x plus 3. Got to play the middle school dance. Variables to one side, numbers to the other side. On the right side, I've got plus 3. Yeah, I'm not so attached to that one. That sweater from Aunt Sally, got to get rid of it because here's me as the variable. Got to get rid of that 3. And I got to keep the kids happy at Christmas time, so I got to do the same thing to both sides. On the left side, 2 minus 3 is negative 1 equals 1/5 x plus 3 minus 3 becomes plus 0. We don't have to write that, but we understand that's there, but it has gone away. And that's the nice thing about doing the opposite of whatever that addition is. We subtract. All right, now I got 1/5 x equals negative 1. I can divide by negative 1/5, but dividing by a fraction is multiplying by the reciprocal. So it's probably just going to be easier to multiply by the reciprocal, multiply both sides by the reciprocal. And I've got, on the left side, negative times positive, negative 5 over 1 times 1 over 1, if you need to put it into fraction land or rational land. 5 times 1 is 5, over 1 times 1 is over 1, but it's negative 5 is the answer over there. Shortcut, negative 5 over 1 is negative 5 equals 1/5 x times 5 over 1, 1/5 times 5 over 1. If we want to go the long way, it'd be 1 times x, 1 times 5 times x over 5 times 1. And this again, I guess it'd be over 1 as well, times another 1. Ones kind of don't really matter. 5's cancel out, and I've got just equals x. 1/5 times 5 over 1 gives me just 1 x. And there's my answer. X equals negative 5. Double check our work. I suppose we can plug this back up in here. Negative 5 times 5 is negative 1. Negative 1 plus 3 on the right side gives me 2. And on the left side is 2. So that one double checks. If we go back and double check our blue, x equals negative 9. Negative 2 times negative 9 is positive 18. 18 minus 7 on the left side becomes 11. Equals 11 on the right side. Left side equals right side. I'm all set. All right, last one on the right side. What do we do with this one? I've got 6x minus 4 equals 2x minus 8. Here's where we play middle school dance. Where does the variable go? Doesn't matter, because we can get to the same answer either way. I'm going to try to say that, you know what, I'm going to move the smaller x's over to the left. And my first thought is move the x's. So I'm going to subtract 2x on the right side. And because both sides are equal, we've got to treat them equally. I'm going to subtract 2x. Try to keep things in columns, because that'll make things really easy to kind of follow, see what's happened to anything. I try to keep my things in columns here as much as possible. 6x minus 2x is 4x. Minus 4 stays the same, equals 2x minus 2x is 0, but we don't have to write that. Minus 8 is still over here. Got to play the middle school dance. I got to add 4 to the left side, and I got to add 4 to the right side as well, because we do the opposite of whatever this is. On the left, 4x still there, equals negative 8 plus 4, negative 4. I don't want to know what 4x is, I want to know what 1x is. So I got to divide by 4 on the left and divide by 4 on the right. On the left side, 4 divided by 4 is 1, invisible 1. X equals, we could just put simply x here. Negative divided by positive, negative 4 divided by 4, 1. X equals negative 1. And if I plug it in up here, 6 times negative 1 is negative 6 minus 4, negative 10 on the left side. On the right side, 2 times negative 1, negative 2, minus 8, negative 10 on the right side checks out. So I've checked it out. Done.